So today we're going to talk about a new theorem called the Hinge Theorem, and it still is the same idea that we've been talking about, seeing which angle or which side is bigger, which one is smaller. But again, we're going to look at two different triangles today instead of looking at just one triangle. So we're going to compare two triangles together. So make sure you're on the side that looks like this. Mine's a little bigger, but it's the side that's got the 2 that says notes at the top. Okay. So the first thing we're going to do is we're going to take a look at what the actual Hinge theorem says. Can I have somebody read for me this first little paragraph? Anybody like to read that for me? Miss Danassa doesn't have to read. Anyone at all? Go for it, Delilah.
If two sides of a triangle are congruent, two sides of another triangle, and the included angle of the first larger, and the included angle of the first is larger than the included angle of the second triangle, then the side of the opposite angle of the first triangle is larger than the side opposite of the angle of the second triangle.
Wow. Okay. There was a lot of words there. A lot of things happening. Okay, so here's all that it says. It's a really, really fancy way of saying something super easy that you already understand. If you're given two triangles, okay, and you're given two sides that are the same, right? So you got one tick mark, two tick marks, okay? You're given two triangles and they have two sides that are exactly the same. The included angle is the one that touches both of the sides. So if you look at the first triangle, which angle touches these two sides? Angle A. If you look at the second triangle, which angle touches these two sides? Which angle is it? D. Okay. So if you're given two triangles, and if you look at the included angle, or the one that touches them, if angle A is bigger than angle D, so let's say angle A is 70 degrees, and let's say angle D is 50 degrees. If angle A is bigger than angle D, then the side across from the 70 is going to be bigger than the side across from the 50 because it's a bigger number. So which side is across from angle A? BC. Which side is across from angle D? EF. So because angle A is bigger than angle D, that means this side is bigger than this side. That's all that the theorem says, because this angle is bigger than this angle. So if this one's 70, let's say this side was 7 inches, well, that means this one has to be smaller than 7 inches. Maybe it's 5 inches. I don't know. It just is smaller. That's all that the theorem says. Because this number is bigger, this side is bigger than this angle and this side. So in general, this is just a bigger triangle. That's all the theorem says. Okay? So if the measure of angle A, so here's angle A, if angle A is greater than angle D, the measure of angle D, oops, this should be this way, my bad. It's an angle. If the measure of angle A is bigger than the measure of angle D, then side BC is bigger than side EF. It's greater. It's a bigger triangle. That's the whole theorem. The converse of the Hinge theorem, converse just means the opposite. So I can go the opposite way. Instead of going from an angle to a side, I can go from a side to an angle. So let's say that side BC is bigger than side EF, right? 7's bigger than 5. If this side BC is bigger than EF, right? This side is bigger than this side. Which angle is bigger, angle A or angle D? So if BC is 7 and EF is 5, which angle is going to be bigger, angle A or angle D? Which one's the bigger number? 7 or 5? 7. So angle A is going to be bigger than angle D. So it's just looking at which side or which angle is a bigger number. That just means it's a bigger triangle and everything about it is bigger. All right, so when we do an example, you're going to see how easy this is. So for each one, we're going to compare the sides and angles by filling in the blank with either a greater than or less than symbol. That's all we're doing. We're saying which one's the bigger triangle, which one's the smaller triangle. So if you take a look at number 1, you're looking at sides KL and PM. So if you look at side KL, it's right here. It's a side. Which angle is across from that side? 79 degrees, angle J. I'm going to put 79 right underneath it. Okay, if you look at PM over here, which angle is across from it? (74) or angle N. Okay, so is KL greater than or less than PM? Greater. That's it. It's bigger. 79 is bigger than 74. That's it. I should know which one's bigger. That's it. It's the whole thing. Not hard. Let's try number 2. AD and BC. The only thing you have to be careful of is making sure you look at the right angle. Here's AD right here. And I always like to highlight as I go through so I know I'm looking at the right thing. Okay, here's AD. Which angle is across from it? 59. Good. So again, I'm going to put the 59 right underneath because I don't want to mess up. Okay, what angle is across from BC? Say it. Which angle's across from BC? 65. So, is AD greater than or less than BC? Less than. 59 is less than 65. That's it. So I just want to know which one's bigger and which one's smaller. That's all I'm looking for. Questions so far? Okay. Number 3, WX and XY. All right, here's WX. Which angle is across from WX? (53). Good. XY is right over here. Now be careful. Which angle is across from XY? Which one? Z. Now, is there anything over here? No. I got a problem, right? Because I don't know what that angle is. But you can figure out that angle. How? Add them and then subtract from what? 180. Yeah, it looks just like the warm-up question. I give you these two angles. If you add them together and subtract from 180, you're going to get what's left over right here. So I'm going to add 93 and 32 together. What is 93 and 32? That is 125. And if I subtract 125 from 180, what do you get? 55. Okay, so this angle right here is 55. I know it's small, I'm sorry. Okay, so I'm going to put 55 right under my XY. So now the final question is WX greater than or less than XY? Less than. There you go. All right. So sometimes you might be asked to find like that unknown angle there, but otherwise once you find it, it's just which one's bigger, which one's smaller. Okay, I'm going to do 4 and 5 with you, then you're going to try the other 3. All right, number 4. PQ and PS. I'm going to start with PS this time. Over here, and here's why. Here's PS. Which angle is across from PS? R. And what's the number for it? 83 degrees. Okay, so I already know PS is 83. Now, if I look at PQ over here, which angle is across from PQ? It's the other side of R, but is there a number given to me here? No. How am I going to figure out that number? What is it? How did you get 97, Enrique? What did you do? Perfect. Straight line, a linear pair. It makes 180 degrees. You already have 83 of the 180. So to figure out what's left over, I'm going to take 180 and I'm going to subtract 83. You get, like Enrique said, 97 degrees. So this little piece is 97. Oh, so small. Okay, so is PQ greater than or less than PS? Greater than. So it opens up towards the PQ. It's greater than. All right, look, here's the truth. 99% of the time, if you are not sure what to do to find the angle, just take whatever numbers are there and take them away from 180. It's like pretty much the only choice you've got. All right, let me do number 5 with you, and then you're going to try 6, 7, and 8. All right, now, number 5 is a little different. Why is number 5 a little different? Of what? What's different about 5 than the ones we just did? It's got M of, this is a angle this time, measure of an angle. So instead of me going from a side to an angle, I'm going to go from an angle to a side this time. I'll go the opposite way. So angle D is right here. Which side is across from angle D? 35. Yep, side EF right here, 35. So this time I'm going from an angle to a side. I just don't actually need a degree symbol there. Okay, angle H is right here. Which side is across from it? GI, which is 33. So, is angle D greater than or less than angle H? Greater than. Good. All right, so you take a moment. I want you to try 6, 7, and 8. Give it a try. We'll check and we'll see if we get the same answer. All right. Number 6, is angle A greater than or less than angle E? What did you get for number 6? Greater than. Very good. So across from the A is the 16. Across from the E is 15. So it is greater than. Be very careful. You're looking at the right angle. Okay? So you don't mess up. Because if you look at the wrong angle, you're going to get it wrong. Also, another way to look at it too is it should be the only number that's different, right? because this one has 12 and 18. This one has 12 and 18. So you don't want to pick the same number. You're going to pick the one that's the different one. It's another way to see it too. Okay. Number 7. Did you get greater than or less than? Less than. So if you look again, you're looking at the number that's different. They both have a 17. So you're looking at the 13 and the 14. The second letter is where your angle is. So RSQ means look at S. You go to S, across is 13. TQS means go to Q, and across from Q is 14. All right. Last one, number 8. Did you get greater than or less than? I heard less. Do we agree? Good. Less than. So if you go across from the first one, you'll get 27. Across from the bottom one, you get 28. So it's just making sure you're looking at the right spot. As long as you're looking at the right spot, easy stuff. All right. Questions on any of those before we go on to 9 through 13? Feeling pretty good. All right. Good. I like that. Now, for numbers 9 through 12, it says find a range of possible values for each variable. Now, what does the word range mean? We talked about this yesterday. It means what? We talked about it. You know what a range is. What's range? Distance. Distance. So it's the smallest it can be and the biggest it can be. It's a minimum and a maximum, right? So yesterday we talked about like what's the range for the third side. We said it'd have to be between, like 2 and 10. Means bigger than 2, smaller than 10, right? A range is a minimum and a maximum value. Okay. So in this problem, it's a little bit different because I have equations. I have a variable I'm trying to solve for, something that I want to find the range of. Okay, so we're going to look at my variable where it goes along. So if you look at the x minus 13, this angle E right here, which side is across from it? 22. So if you go across from this angle, you get 22. If you go across from the 75, what's the length given to you? 23. So if you're looking at these triangles, which one is bigger? The one on top or the one on the bottom? The one on top, because 23 is bigger than 22. So this is my bigger triangle. This is my smaller triangle. Okay. So I know that this triangle is smaller because this side is smaller. That means this angle right here has to be smaller than 75. It has to be less than that number because this is smaller triangle. It's a smaller side. So I'm going to write that as an equation. I'm going to say this angle right here, x minus 13, is smaller or less than the other angle right next to it, which is 75. So my x minus 13 has to be smaller than 75 because it's a smaller triangle. Now, I'm going to solve this like I would a normal algebra problem. Pretend that's an equal sign. What would I have to do first to get the x by itself? I would just add 13. So I get x is less than what? Excuse me. What's 75 plus 13? 88. Okay. So the maximum value I'm allowed to have is 88. It has to be less than 88. Can't be any bigger than that. That's my max. Now, range means I need a maximum and a minimum. What kind of number are you not allowed to have for an angle or a side of a triangle? What kind of numbers don't make sense? Negatives, exactly. So I don't want this to be a negative number over here. So to kind of get rid of that or combat that so I don't have a negative, I'm going to take this equation again, x minus 13, and to make sure it's not a negative, it has to be greater than 0. Because if it's bigger than 0, it's not a negative number. It's always going to be bigger than 0. Always, 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 because you never want a negative number. It doesn't make any sense. Okay, same as the last one. I just want to solve for x. So what would I do first? Or what was my only step, actually? I'm 13. So I got x is greater than 13. So I need to pick a number that's between the range of 13 and 88. So it has to be bigger than 13, less than 88. What would be a number in that range? Bigger than 13, less than 88. What's an example of a number in that range? 30. What's another one? What? 20. What's another one? 70. What's another one? 50. Yeah, any number that's bigger than 13 and smaller than 88 works for that. So now I'm going to write it as one final equation, or one final inequality, excuse me. Just like how we wrote our ranges yesterday. I'm going to say x is less than 88, but greater than 13. So it's a number between 13 and 88. And so if that was a test, you could put any number you wanted between 13 and 88. Yes. Mm-hmm. All right, let's do number 10, and then I'll let you try I'm going to try one on your own. All right, we're going to do the same thing we just did. I'm going to start by looking at my equation, 2x minus 16. Here it is. Okay. Which side is that across from? 39. Okay, the other angle I'm given is 36. Which side is that across from? 50. Okay, so which one of these is the bigger triangle, the left one or the right one? Left one's bigger because 50 is bigger than 49, right? So this is my bigger triangle. This is my smaller triangle. Okay. So, knowing that this is the smaller triangle, I'm going to write 2x minus 16 is what? Is it greater than or less than the 36? Less than. It's a smaller triangle. So it's less than 36. My 2 degrees, right? This was my degree. This was a degree. All right, now, again, pretend it's an algebra problem, pretend it's an equal sign. What would you do first? Add what? Add 16 to both sides. So I get 2x is less than 52. And then what's my last step? Divide by 2. I get x is less than 26. Okay, so that's my maximum. It can't be any bigger than 26. It has to be a number smaller than that. Okay, and in the last one, Victor told us what kind of numbers are we not allowed to have? Can't have negatives. So now I'm going to take this equation and make it greater than what? Has to be bigger than 0. So 2x minus 16 is greater than 0. You're literally always going to make it greater than 0 every time. All right, again, it's an algebra equation. What should I do first? Add 16. I get 2x is greater than 16. And then what's my last step? Divide by 2. So my x has to be bigger than what? 8. So my x value has to be bigger than 8, but less than 26. What's an example of a number in that range? 16. What's another one? What? 21. What's another one? 10, right? Anything bigger than 8, less than 26. My final step is I write it as one inequality. X is 26, but greater than 8. All right. 24, what time are we done in here? Okay, perfect. So you're going to try number 12. Number 12. Give that one a try. We'll see if we get the same answer. So skip 11 for now. Go straight to 12. See what you get. This one go ahead. So if you're stuck, you should definitely take that equation and always start by making it bigger than 0. You better start there. That's a good place to start. Make it bigger than 0. Make it bigger than 0. Directions. Yeah, there you go, good. So always start by making it bigger than 0. Good, good. All right, check yours with mine. So always start by taking your equation and making it bigger than 0. It's a great place to start. That'll give you your minimum every time, bigger than 0. Add 4, both sides, divide by 2, x is bigger than 2. Then, your angle is less than this angle right here. So keep your angles together. I saw somebody do, this is less than, I think, 48. Be careful, they're both angles, so keep your angles together, okay? 2x minus 4 is less than 28. Add 4 to both sides, you get 16. So I need to pick a number for my range between 2 and 16. All right. We're going to start on 13. I don't know if we'll finish it. We're going to skip 11 for the moment. We're going to go straight down to 13. All right. 13 says, list the angles of triangle ABC in order from least to greatest. And then I give you a whole bunch of equations. and I tell you the perimeter of the triangle. Okay, first thing we're going to do is we're going to draw a very large picture, and you can take up a good amount of space because you've got a lot of space there to work with. We're going to draw a nice big triangle ABC. So I'm going to put A at the bottom on the left, B at the top, C on the right. Okay, now it wants me to list the angles in order from least to greatest, and then I give you a whole bunch of equations for each side. So we're going to take those equations and mark them in the picture. So AB is 6x minus 35, so I'm going to come to AB, I'm going to write 6x minus 35. Side BC is 4x plus 11, and side AC is x plus 29. So I'm just taking those equations and putting them into my picture. All right, now it tells me all these equations, and it also tells me the perimeter of the triangle. What does the word perimeter mean? Perimeter. The what?
All sides.
What about all the sides? So if you think about, like, if you have your house and you put a fence around your house, that's the perimeter. It's the distance around something. It's how far I would have to walk to go all the way around the school. That's the perimeter. So in this picture, it's telling me, Miss Masso starts at A. If I walk to B, then to C, then back to A, I walk a total of 192 units, whatever it is. So I want to write an equation that says, if I start here and I go all the way around, it should be 192. So what should I have to do with these three equations? Do what? Add the equations together. Yeah, so let's, I mean, if this was 1, 2, and 3, right? If I walked 1, then 2 feet, then 3 feet, how many feet did I walk in total? 1 plus 2 plus 3, right? So that's exactly what I'm doing here, except with an equation. So I'm going to take this plus this plus this and set it equal to 192. So 6x minus 35 plus 4x plus 11 plus x plus 29. So all three of those equations added together equals 192. Okay, what should I do first? Very long equation. But what should I do first? That very long equation. Combine like terms. Which like terms can I put together? The x's. So I've got a 6x, a 4x, and an x. How many is that in total? 11 x's, right? If there's no number in front, you can put a 1 there. There's 11 x's. Okay, what else can I put together? Put all the x's together now. Can I put all it together? Perfect. I can put all the constants together. Negative 35, positive 11, and positive 29. So 29 and 11 is 40. 40 minus 35 is 5. Positive 5 equals 192. Okay, what should I do now? It looks way easier now. Minus 5 from both sides. We get 11x equals 187. Now what's my last step? Divide by 11. I get x equals 17. Whew. All right, so we put all of those together. Put them up to my perimeter. Am I done with the problem? Nope. Why? I gotta plug it in because it asks me to list the angles in order from least to greatest. That doesn't help me right now. I gotta take that 17 and plug it into every single equation. All three sides, because you're gonna get 3 different answers. So I have to do 6 times 17 minus 35. 4 times 17 plus 11. 17 plus 29. So I have to plug that 17 into every single x, substitute it in. Okay, to save us some time, I'm just going to tell you what those numbers are. Okay. So the first one, AB, is 67. Side BC, when you plug that in, is 79. And then side AC, when you add 17 and 29, you get 46. So I have the length of all three sides. The last step is it wants me to list the angles in order from least to greatest. Okay, what is the smallest angle? Marissa? No, because we have 1 minute left. Which one's the smallest number? Yeah, 46, which is across from angle B. What's the next smallest number? 67, which is across from C. And then what's your greatest angle? 79 across from angle A. All right. So tomorrow we are going to finish up that number 11, and we'll finish the back side tomorrow during class. So you do not have any homework tonight? If you didn't submit your homework from yesterday, make sure you do that. It's open tonight still. And there are also 2 extra credit assignments online that close in about 2 weeks. So if you want to start looking at those extra credit assignments, it's not a bad idea. All right, my dears, have a lovely day.